Hi and welcome to another very exciting series of tutorials in the 24 Days of Swift Tutorials series. Well, what we are planning now is going to take some time. Let me explain the roadmap for that. We are going to build a to-do application, of course, from start to finish in the next few days, so we're going to have a bunch of videos here. Our goal for the next 3 days is to create such a prototype of a to-do list application. This application has some quite nice features, something that you would of course expect. We need to save to-dos, load to-dos, delete to-dos, and the share to-dos feature is something special because we are going to use the multi-peer connectivity framework for that so that you can instantly share to-do list items with someone nearby who also has the same application installed with the press of one button. Actually, this is really, really cool. So wirelessly, just transferring it via Wi-Fi or Bluetooth. And of course, we should be able to mark items as completed. Some of the videos are quite long. Even this one is maybe going to take about half an hour. So you maybe want to save some time for that and go through each step if you're interested. And so just a quick overview. Today, day one, we're going to create a data model for local persistence. So we're not going to save that anywhere in cloud. There is an option, of course, to save these files that we're going to create in iCloud for synchronization. And they are stored in the documents directory of the user, so they are also backed up in iCloud. But we're going to focus on local persistence in this series. Tomorrow or in the next tutorial, we're going to create the prototype UI and some of the basic features. Day 3 is going to be about implementing the multi-peer connectivity feature and the share feature of our to-do list application. Day 4 is going to be about creating a better and cooler UI design for this application, and day 5 is the final day for this tutorial season where we are going to implement the design changes, and this design that we have created in Sketch will bring that to Xcode. And I think this is going to be really, really cool. So just a quick reminder, if you haven't seen it yet, and maybe there are some new viewers here who are not familiar with the Slack community that I have created for this channel. So you can join the Slack community for free with the join link in the video description below. And this is a place where you can ask questions and help each other out. And also I am able to help you there from time to time with your questions about iOS development and Swift development in general. So definitely check this out. And now let's focus on today's topic, which is creating a data model for local persistence. And the interesting aspect of that, and we're going to focus on modern features of Swift 4 actually, we will create our data model as a struct. So we'll have a to-do item struct that has 3 properties or 4 properties later, where we have a title for our to-do item with a completed flag and a created add property for that so that we can sort these items later. And notice this little codable statement or this codable word in the top right corner of this code snippet. This is actually the adoption of the Decode protocol, which allows us to translate this struct, a data type, into JSON code. So this is a data representation of our model as JSON. And because we have adopted this Decode protocol for our data model, we can very easily transfer our data model from our properties into JSON code and then save a local representation as a local binary file from this JSON code and load this data and get it back into our application and of course override it and so on. And all of that is possible because we are going to adopt the Decode protocol, which is a type alias for encodable and decodable. And this allows us to use a JSON encoder and a JSON decoder. You're going to see that in action in a few moments. So our goal for today is creating a data model for a to-do application and also creating a generic manager for local persistence. So we're creating a class that will enable you to actually store any kind of data model on file or on disk on a user's device, because it's going to be so generic that you can put in any kind of codable data type that you create. Today, we're going to create our project, and we are also going to set up the data model and everything necessary to actually save data to disk to our iPhone's document directory. And therefore, I'm going to create a new single view application. I'm going to call that to-do app and hit next and create that on my desktop. And what I'd like to do now first is resizing my window here a little bit, and then we're going to create our data model as a struct. So I'm going to press Command N with my view controller selected, and then we're just selecting a Swift file here. So I'm hitting next, and this is going to be my data model. I'm going to call it to-do item. So let's click create, and here we have an empty Swift file just with the foundation framework imported right here. And now we are going to define such a struct for us. And this struct is going to be named to-do item. And now the most important aspect of this struct, of this type that we're now going to create, is that we define it as codable. And as you can see here, this is a type that can convert itself into and out of an external representation like JSON, for example. And this is very important now that we inherit codable, or that we adopt the codable protocol right here. And now we only need to define the properties that we're going to need. So first of all, we're going to need a title for our to-do item. Then we also need kind of a flag that is going to tell us if this to-do item is completed or not. So this is going to be a bool. And we're going to have a created add property that is going to be used to sort the to-do items. So this is going to be a date. And last but not least, we're having an item identifier of type UUID. This is a universally unique value that we can use to identify each to-do item later. And these are all the properties that we need. And since this is a struct, an initializing function comes with it automatically. All we need to do now is also define some functions here, like save item. This is something that we're going to need. We're going to need a function to delete an item, so delete item. And we are going to need a function to mark an item as completed, so just call it mark as completed. And these are all the functions that we're going to need, and we're going to implement them later as we're moving along. But as you can see, this is very simple to define such a data model for our application. Now we're actually reaching the interesting aspects that we're going to deal with, which is going to be a data management class, or a class data manager, that is going to help us with everything related to storing something on disk and also encoding that in a way that we can use it properly with the codable struct to-do item right here. So I'm now selecting my to-do item, pressing Command N again on my keyboard, and just selecting a Swift file again, and we're going to call that data manager. Hit create, and that's all there is to that. And again, we're just working with the foundation framework here, and we're first of all going to define a public class data manager right here, manager, some curly braces, and then we can get right started. And now I'm going to add some comments here for what we actually need. So first of all, we're needing a function that gets the document directory so that we can actually access the document directory and save information there. We're going to need a function that saves any kind of codable objects like our to-do item, but you are going to be able to use that class for any data model that you create that has properties in a struct and that is indeed codable. So whether you're creating a to-do application, a notes application, or something completely else, as long as your data model is codable, you can use this data manager to actually save files directly on disk. So we need to save something. We also need to be able to load any kind of codable objects. This is the next step that we're going to take. Then we need to be able to just load data from a file. So we're not interested in the actual JSON representation. We're interested in the data. And we're also going to create a function that loads all files from a directory. So these are going to steps that we're going to take right now. And there's one thing that I forgot. We need a function to delete a file. And this is the last function that we're going to implement. So let's start with the easy part. And as you're going to see, all of our functions are going to be defined as static. And the reason for that is that we actually just want to access these functions without needing to create an object of our data manager class. So we can just write data manager and use the function getDocumentDirectory, for example. But this document directory function should only be accessible in this file. So we are also declaring it as file private. And then we're creating this function getDocumentDirectory. We do not need any parameters here, but what we'd like to return is a URL. And the first thing that we need here is, of course, the URL for the documents directory. So I'm using a file manager, and I'm using the default file manager. And this is just a class that comes with the Foundation framework. And I can use that now for URLs for a search path directory in a domain mask. And what I'd like to use here, of course, is the document directory, not the downloads, not the documentation, nothing but the document directory. And what I also need to specify is now the search path domain mask, and this is going to be the user domain mask. And as you can see, this is the user's home directory and the place to install user's personal items. So this is exactly what we need. And here, from this array that we get here, we're just taking the first element. And if this works, and if we get indeed a URL, then we can return this URL. And in any other case, if this fails, then we just create a fatal error message here and say unable to get or to access document directory. So this is the first step that we need to take. We now can access the document directory. And now this is really fun because we're now creating a function to save information using JSON and JSON encoder. And also, this is going to be a generic function, a static and generic function. This looks now maybe a little bit complicated, but it isn't. We have a static function, so we can access this function without creating a object of this class data manager, and we're going to call it save. Now, so far so good. This is everything you might already know. But now we are going to define a type for this generic function using a uppercase T and defining this type as encodable. And with that, we're specifying what kind of objects we can actually receive here. So let's define an object parameter here with the type T. And all this type needs to respect is that it is encodable. So we can put any kind of codable object into this function. And then we're defining a file name, so with file name and string. And we need nothing here to return. So this is our generic function that we're now going to use. And the first thing in this function that we need is, of course, the URL. So I'm just accessing getDocumentDirectory. And now I can append a path component with the specification if this is a directory or not. So I'm now going to just append my file name to actually have a file name for my object that I'd like to store on disk. And this file is not a directory, so I'm adding false here. It is a file. So with that, I have a URL that points to my future file that we are going to create in our document directory. So now that we have that, we create a new object of encoder, which is a JSON encoder. And this is going to make or enable us to actually create a file that is a JSON representation of our data model. And we're going to do something that can throw an error. So we're using a do try block here. And first, before we try anything, we're creating a data object here. And now we try to use our encoder and encode an object. And as you can see, this can throw an error. And here we're passing along our object. And this creates the JSON encoder creates a JSON representation of our data model, and then gives us a data object that we store in this data constant. And this is really cool because this is something that we can save to disk. So let me first of all add a catch block here, and if an error occurs, then we just throw an error message with the error and its localized description. So let's quickly build that, and we shouldn't get any errors here, and this is fine. We have got an error because I have not selected a simulator here and did not specify a development team, so I have no provisioning profile, but it doesn't matter right now. So when I build that using a simulator, we should be good to go, and indeed we are. And now that we have a data object that we can save to disk, we can again access the file manager in an if statement. So I'm using the file manager default, and I'm checking if a file exists at our path URL and accessing its path already, because this means that I'd like to overwrite an already existing file. So this is just a quick check, and if this indeed returns true and a file already exists with this name, then I use my file manager, the default file manager, and I remove the item at the specified URL. So, and if this is not the case, then we just continue, and we're using the file manager again, the default manager, and then we create a file at a path with contents and some attributes that are going to be nil for us. So the path, again, as the URL, and its path as a string. And as a data object, we can simply pass along the data that we have created, which is a JSON encoded object of our data model. And we do not need to specify any attributes here. So this is all there is to it, to actually save a file with a generic function that can receive any kind of codable object. So now let's do the reversed thing. Let's load data, or let's load a file that we can work with. So again, we have a static function. We're going to call it load. And again, we're going to specify with T a decodable object here that we can receive. And again, we're going to need a file name, which is a string with a specific type. And again, we're using T, uppercase T, as our type that we can actually work with here as a parameter. And we also want to return a type T, because this could be any kind of decodable object that we received here as a parameter. And just for you to understand that better, because we have defined the T as decodable here and here as encodable for save, when we're adopting the codable protocol, then we're actually adopting decodable and encodable. And codable is just a type is actually just a type alias for decodable and encodable. So let's switch back to the data manager. And in load, we have to do the reverse thing. So what we again need is the document directory and the path component with our file name. So I'm defining a URL using get document directory. I'm appending a path component, and again, I'm using my file name for that. And again, this is no directory here, so let's use false. And with that, we get a URL that points to the file that we're actually looking for. And the next step is going to be to check if the file exists, and if not, if the file manager and default file exists at path, so url.path, and this does not exist, then we cannot continue. So we have to throw a fatal error again, which says file not found at path, and then we can just append the URL and its path right here. And then we just cannot continue, but if it works, then we can continue and we can get some data. again from the file manager, default, and then contents at a specific path, and the path we get with url.path. So, and if we have our data object right now, we can actually create a model object that we can return, and this model object is, of course, just required to be decodable and adopting the Codable protocol. So we're actually creating a object of type to-do-item in our case now by decoding what we get here. But we're creating this generic kind of function here. So again, this is going to work with any kind of decodable or codable model object that you're going to use. So let's use a do statement here, or a do block, because there is a possibility for an error occurrence, and I'm creating a model object now. And what I'd like to try is using a JSON decoder and call the decode function. And this requires us to specify a type, and we already did that. We have a type here in the parameter list, but what we still have to do here is specify that we're interested in the type here. So I'm just using the uppercase T and access its type. And now that we have that, what we also need to do is now decode with a specific type from our data object. And with that, we can actually load or decode any kind of codable information into a model object that we can then return from our function. And then, of course, we have to specify a catch block here. We're throwing a fail or error if this did not work, and using the error here, error, and its localized description. And if the file manager could not load our data, then we're also going to add an else statement here with a fatal error saying that the data is unavailable at the specified path, again using the URL and its path for further information. And that is all there is to actually load data from a file and putting it into a model object, into actually any kind of model object. And now, last thing that we'd like to do is just load the data without actually converting it into the model. So I'm just copying all of that stuff right here, adding that to the load data from a file function, and all we need to do here is just using a file name. We do not need a type here, and we're actually returning an optional data object right here. We do not need the specification for a generic type here, just calling the function load data. But many of the things that we already did are exactly the same. So we're again needing the URL. We need to check if the file exists, and if not, we throw an error, and we need to check if we can get some data. And what we do not have to do is all this do and trying. So all we need to do here is return the data. And so we have a function that just returns the data without converting it to a object or a model object. So this is the one of the last functions that we needed to create. Now the last one that we're going to create is going to load all the files that we have at a specified directory or in our document directory, because this function just loads one file. So how can we go about that? So let's first of all define that as a static function again. Let's call it load all. Again, I have to use a generic type here, which again needs to be decodable, and we just need to specify a type here again. So again, uppercase T and type, and we want to return an array of this generic type T. And what we have to do here is getting, first of all, a list of all the files that are located at a specific directory. And there can occur errors again, so we're using a do block and creating an array of files. And here I'm using a try statement for file manager, default, and contents of directory. And as you can see, this can throw an error. This is why we're using a do try block here. And the path that we're going to use is to get the document directory and its path again. And if we have now a list of files, then we can create a variable with model objects, or an array of model objects. And I'm initializing that right now with our generic type. And this is just an empty array now, and I defined it as a variable because we're going to change that. Before I continue, I now just add a catch block here for the fatal error that could occur, and we just say could not load any files right here. But now let's continue with our array of model objects. And here I'm just using a for loop to iterate through file name in our files list. This is just a list of strings. And then what I can actually do is use my model objects array and just append the results of my load function. So I'm passing along my load function right here. I have a file name that I can specify now, which is file name from our loop with the type that we're looking for. So just pass along type right here. And with that, we have now an array that we can return after iterating through our files array. So I'm just returning now my model objects. And with that, I have a cool function that can actually load all the files in a given directory. And the last thing that I'd like to do now is having a function that can delete a file. So let's call this delete, and also this is going to be static function delete, the file name, which is a string. We need an URL for that. So I'm using my get document directory, appending a path component, not a path extension, which is going to be file name. This isn't a directory, so passing along false. And now I'm using my file name manager, if file manager default, and the file exists at a path, url.path. Then what I'd like to do is again do try, use the file manager default, remove an item, add a URL, and if this does not work, let's use catch fatal error, and let's print the error and its localized description here. Let's build that really quickly, and that's it. Now what we have is a cool and generic function that you can use to actually save, load, and delete all different kinds of model objects that you can create. As I said earlier, we can use it for to-do items, you could use it for notes, or any other kind of model objects that you would like to persist on disk using a JSON encoder. So now let's quickly test that in the simulator. Let's create a to-do item in our view controller class in view.load. So to-do item, create a to-do item, and now the cool thing about our struct is that we can actually initialize it without having to create an initializer. So the title is going to be do next tutorial. It is not yet completed. I'm creating it right now, so I'm passing along date and my UUID. I'm defining that using UUID and just initialize that. And with that, I have a to-do item, and now I'd like to save that. And therefore, we already created a function in our to-do item. So all I need to do here now is to access my data manager and save an object. And the object that I'd like to save is self. And the name of this object, or of this file that I'd like to save, is going to be my item identifier and a UUID string. That's all there is to it. And to delete a file, I'm using my data manager again, using delete with the file name, item identifier, and the UUID string. And now the last thing that I'd like to do is mark as completed. Therefore, I'm just using self and completed. And because now I'm changing an object here, or a property of this struct, I have to define this function as mutating. So in any other case, if I do not define this as mutating, then this would not work. And after I've set the completed flag to true, I can use my data manager, hit save. The object that I'd like to save is self with the item identifier and its UUID string. So let's build that again and go back to our view controller. And now I can use my to-do item and just hit save item. And if I now run this in the simulator, then I should actually be able to see no error messages if everything worked out nicely. And if not, if we made some mistakes, then we might get an error result in the console. But if it just runs fine, then this should have worked. Now let me create just another to-do item here. And this could be read news run this again in the simulator. With that, we have created 2 to-do items, and we should be able to load them in the next step. Again, this worked. And now I'm going to use a new function here. Let's call that to-dos, and not a new function, of course, a new object. Now I'm using my data manager, and I'm going to call the load all function. And what I'd like to load are items of the type to-do item. So I have to specify to-do item.self to actually load that, and then I can print my to-dos. And that's all there is to it. And the cool thing here is that, as you can see, that this to-dos object here was already recognized as an array of to-do items. And this is really cool because this is how we created our generic function load all. And since we put in a to-do item object here as a type, we actually also get the result as a to-do item right here. So let's now run this in the simulator and see if we get our to-do item right here. So now what we have are 2 items. We have the new do next tutorial, and we have the read news to-do items that we could display now in a user interface, for example. And this is indeed what we're going to do, but in the next tutorial. I know that this was a little bit theoretical maybe, or it was not as visual as usual, but data persistence isn't a very visual topic, so I hope you still enjoyed creating such a generic class that is really versatile and that you are free to use for your own projects. Just go ahead. And I hope this is useful to you. If you like this video, give it a thumbs up, and don't forget to subscribe to this channel. I thank you so much for watching, and I'll see you in the next tutorial tomorrow.